So let's do another example. Let's say that we have a careless mechanic working on a car. And so we got a 12-volt battery here, and the mechanic has a wrench and lays the wrench across the terminal of the battery. Okay, so let's say that from where one part of the wrench the other part connects is going to be 22 centimeters. And let's say that the wrench has a cross-sectional area in here that's 1 centimeter wide, and it is 3.5 millimeters thick. And so the question is, how much current goes through that wrench, and how much is it heating up? So in other words, what's the power dissipated? So I want to know the current and the power. We work this the same way. We got to find, we imagine this as a resistor here on a battery. So 12-volt battery, resistance, we find the current. Okay, and so what we do is we have to find the resistance. So the resistance is rho L over A. Now you need to know what rho is. So we're going to assume that this is made of steel. So it's a steel wrench. And so the rho of steel is 6.9 times 10 to the minus 7 ohm meters. Okay, so R is going to be it's going to be rho L over A, so that's rho L over, well, the cross-sectional area is going to be the length and the width so in other words, we got this wrench right here, okay, it's going to be the cross-sectional area, so it's going to be the width of it and the thickness of it. So this is the width and the thickness of it. So R is going to be 6.9 times 10 to the minus 7 ohm meters, and that's going to be times 0.22 meters, because 22 centimeters long, divide by 0.01 meters, and 3.5 times 10 to the minus 3 meters. So the resistance is a puny 4.34 times 10 to the minus 3 ohms. So in other words, the resistance is 4.3 milliohms. Okay. So the current is V over R, so that'll be 12 volts divided by the 0.00434 ohms. So the current is going to be a huge 2,800 amps. Now, in reality, an automobile battery cannot provide that amount of current. At this point, there's something else that physically limits how much current it can put out. But still, this is a huge amount of current that's possible. So what will really happen is the battery will max out its maximum current output. But if assume it did do that, what would be the power? It'd be I squared R, so if you plug that in, that's 34 kilowatts. Okay, so even though this is unrealistically high, it would still be a huge current that goes out, and so you'd still have a huge power dissipated. And what will happen is, if you leave it on there, it'll actually very quickly get so hot that A, it'll burn you if you try to take it off. B, the ends of it will actually melt the terminals of the battery and sort of weld it to the battery, and so just keep going, but there's a limit to what the battery puts out because the battery has its own resistance. So the battery will start heating up, and when it heats up enough, you start boiling the sulfuric acid inside the battery, at which point the entire battery explodes. And then that's going to be really annoying if you happen to be nearby.